you able to see clearly? Are you seeing it clearly? Okay. Okay, we can review what we did last week. Was there any problem? Was anyone experiencing any issue with what we did on Monday? Did you log into your Newton account? So, who doesn't have the account?
I just got mine today.
Okay. All right, I can give you the deadline for maybe Friday. You make sure by Friday you finish with section 2.3, and then I think on Monday you should be done with all the other sections. Okay. All right. So last week on Tuesday we were looking at how we can make the variables the subject of the formula. So we said if you have something like L equals to maybe length times width times height, then you're able to make either one of them the subject, then you're able to divide by that and also that one, and then you say L equals to length over, okay? Yeah. So I think we did not have a lot of issues with that. And then also there was something which I forgot to tell you concerning this one, the right angle triangle. Yeah. So here, these angles are always adding to 180. So if this one is A and this one is B, then A then A plus B plus, we always know that this is what? 90 degrees plus 90 degrees equals to what? 180 degrees. So you can be told to find this value of B or to find the value of A. Okay. So using the same way with what we did, then if you're given B and or A or something like that, then you're able to solve the others either way. So you can say A is, let's say, 50 degrees. Then B would be equals to A, which is 50, plus B plus 90 degrees equals to what? Equals to 180. Okay? Then you can take all these to the other side. So when you take 50 here, because this one is positive, then goes here, it will be what? Negative. And then when you take this 90 here, because this one is positive, then it will be what? Negative 90. So you get the value of B there. I don't think you have any issue with that. So if you have any question, please don't hesitate to. You can text me or you can even write a mail to me. All right, let's come to what we are supposed to do today. So we are going to section 2.5, which is solve linear inequalities. This solving linear inequalities. So we always have the inequalities, which are this one, this one is the what? Equal what? Equal sign. We have this, which is what? Greater than. Then we have this one, which you can say this one is what? Less than. Then we have also this, yeah, which we can say this one is what? Greater or what? Greater or equal to. And then we have that one, which is what? Less or equal to. Then the most, at some point, we can have that. Which you can say this one is not equal. Okay? So here, we will be looking at these inequalities here. The greater than, the less than, the greater or equals to, the less or equal to. Okay, and then we're going to represent this one in the Cartesian plane. We're going to represent these values here now. We always start from 0, then going this way. This one is what? This one is the positive, and then going this one is what? The negative direction. Okay. So when we are representing this or this greater or equal to in the Cartesian plane, then we always have some of the books they use this way. If you have the Cartesian plane there, if we say we want to represent, let's say this one is 0, then that way, if we want to represent this value, let's say this value x is less than 3. X is less than 3. Then if this is -1, -2, -3, this one is 1, 2, let's say we go there, 3. Yeah. So we go to the value where there is what? 3, okay? So x is less, the values of x are less than 3. So anything which is what? Less than 3 is the value of x. So therefore, here we can use, I usually use the circle like that. Okay, I don't know whether you use that on your high school or something like that. So if it is less or equal to, oh no, if it is less or greater than, then we don't shed the circle. Okay, so you leave it like that, blank like that. So that means these are the x is less than 3. So therefore, they should be in what direction? That direction, okay? Okay. So anything which is here is less than 3. So 2 is what? Less than 3. 1 is what? Less than 3. 0 is what? Less than 3. So that means we are not including value of what? 3. We are not including this 3. Now, if we have 3 that way now, x greater than 3, okay? So therefore, you draw the Cartesian plane like that. Here is 0, and then let's say we have there 3, okay? So the values of x, we are not including what? 3. So the values of x are greater than 3. So they are going this direction. So they are going like that. And we don't what? We don't shade the what? 3. So we leave it like that. So that means this one is x greater than 3. Okay? So other books can write it like this. So other books can write like this. So if we have 1, 2, 3, -1, -2, like that. So if it is x greater than 3, yeah. So some books usually use this, that bracket over there. So here they can write like this. So you can also write like that. Okay. Then you put that one. So this is x greater than 3. Also, if it is x less than 3, then you can also put like this, -3, then okay, so this is x less than 3. All right. So we can. So which one do you prefer?
I like parentheses.
You like this?
Yep, I like parentheses.
Okay. All right. So when it comes to now x greater or equals to 3, this is where we include values of what?
3.
So here you draw it like this, okay, 0, and then this one is 3, and then we use this. We either use this or we use that one, okay. So for our case, this is x greater than 3. So these are including the values of what? 3. So this is x greater or equals to 3. Or you can write it like this. 0, 3, then like that, and then you shade. Then you write like that. X greater or equals to 3. Okay. So you can always write it like that. All right. So the notes are online. So I put them in the Moodle so you can check them. Okay, so these end brackets are using this one to show there is what? Not included. And then the endpoint for this one showing that what is included. So the example is this. So when x is greater than 3, so it's like this. So you use that. Okay. So this one is showing x greater than 3. Okay. So this is what we call the notation. So here, before we go to that, then let's come to this. So when x is less than 1, means the numbers less than 1, less or equals to 1. So we include the values of 1 there. Okay. So here, if it is this, then we use the brackets that, and then those are the values which are in the negative direction. So that way, then here again, this is like that. So this one is what we call the interval notation. The interval notation. Okay. Now, if we have the value of x greater or equals to 3, okay? So the question can be, draw the Cartesian plane or the graph for this one, and then you write the interval notation for this. So the first step is, this one is that, then you draw now. So this is 1, 2, 3, 4, and then continue like that, -1, -2, like that, and this one is 0. So because this is including this value, then we use what? We use that. Then you put this one. So you can put it over here, or you can put it on top there. Okay. So this is x greater or equals to 3. So interval notation for this is the value of x. It's in this side. Okay. And then the other value is in the other side. All right. It's in this side. So the other one is in the other side. So you start from this. So it's 3 here. And if it is including 3, then you use that. Okay. So it is in this side, and then the others are in the other direction. So the next one is going to what? Infinity. So this is what we call the infinity. And this infinity is what? Positive, right? So it's in the positive direction. So, and this infinity, we don't know the end. So that means it's just, we don't know the end. So that one is what? It is open. So this is also what we call open. And this one is closed. You will still use that one maybe later in mathematics. So those are the values which are going to the positive direction. Now, if it is, let's say, x less or equals to maybe 1, like what we have in our notes, then this is 1, the first step. The next step is you now draw. So this is 0, this is 1, this is 2, that way, this is -1, like that. So this one is 1. And this one, the values of x are what? they are less, right? They are less or equals to 1. So therefore, this is including the value of 1, and then they go this direction. So therefore, what did we say? We are starting from what? The left. So this, in this case, the left is what? Open, right? And then we are not including, then negative that one. And then the last one is 1. And that one is closed. Okay? So we are including the values of 1. Are we together? Any question? All right. Okay, also you can try this. So in this case, then this one is x greater or equals to -3. So here you draw that. So this is 0, -1, -2, -3. Then doing that one is 1, 2. So x is greater or equals to -3. So how are we going to draw this? So the values of x are greater or equals to -3. So where are we going to put this? Now, if we go this direction, that means now if we go this direction, is -2 greater than -3?
Yeah.
Is 0 greater than -3? Is 1 greater than 0? So that means it is like this, right? And then we go in that direction. So this is x is greater or equals to -3. Then in terms of interval notation, then we start from what? -3, and then it is like that, and then what? Infinity, and that one is like that. Okay. All right. So let's come to this. So if you're given -3, and then that one is x is greater than -3, and also x is less than 4. So here, you can draw the Cartesian plane. Okay, should draw something. So -3 x 4. So that one is the first step. You write that. Then we have the Cartesian plane here. So this one is 1, 2, 3, 4, -1, -2, -3, goes down. This one is 0. Okay. So x is greater than -3. So this one is what? Are we including -3? No. So -2 is what? Greater than what? -3. So it will be like this. Okay. Then let's come to this. X is less than 4. So we are at 4. So it is less than 4. So that means -3 is what? Less than 4, right? 2 is what? Less than 4, right? So, and then we are not including 4. So it will be like, so this one is our region. This is the region x less than -3, and this one is the region x is less than 3. So in terms of interval notation, then this will be what? We start from this, right? So this is -3, and then this one is 4, and then
Yeah, we can't quite see the bottom of the page.
oh, you can see it? Okay, all right. So this is not including 4, and it is not including 3. Are we together? Any question? All right. Okay, you can try this. Try this one. -2, x 1, and then try also this -5 x -4. Let me give you like 1 minute. You try it and then we discuss. So easy, right? So here, so simple, you draw that. So this you can put here -2, then you can put here 1. So this is open, so it's like that. This one is also open, like that, like that. So this is this one. And then interval notation will be -2, 1, that. So the next one is like that. So you can put here -5, then you can put here -4, 0 there. So this is including this, and this one is also including that. And then this one is the region. And then the interval notation will now be -5, -4 there. Yeah.
Why did you put the 0?
0?
Yeah.
So this one is the, let's say the starting point for each of, because now next one here is 1, right? 2 like that. So here is, I did not write everything. So I had to just put 0 there, the starting point. So -1 like that. I omitted the other ones. Please try to, because we are adding, then try to put all those values there, okay? But if it is what?
You have a -5 and a -4, so we do 0 between the two, is what we're thinking.
No zeros.
Between the
Oh, okay, okay.
There you go.
Yeah. I did not check. Okay, 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 okay. Okay. So, sorry for that. So this is 0, right?
Yeah.
And then there is, let's say, -4 here, and then there is -5 here. Sorry for that. So that one is like that. So this and that. So this one is the region. All right, okay. Thanks for that. All right. So are we together? Okay, let's go to the next section. So you can also go and try this. It's in Moodle. -1 is x greater or equals to -3 and then less than 1. So let's go to the properties of inequalities. The properties of inequalities. Okay, so addition, subtraction property. So if the real number is added or subtracted from each side of the inequality, the resulting inequality is equivalent to original inequality. So we'll look at an example of that. Multiplying and dividing the property. Multiplying or dividing each side of the inequality by the same positive real number produces equivalent inequality. Okay, so this is very important. Multiplying or dividing each side of an inequality by the same negative real number produces equivalent inequality, provided the direction of the inequality symbol is what? Reverse. So when you multiply or divide by the negative, then you reverse the what? The inequality. Okay. So if this is x, let's say less than 1, and then you multiply by the negative here and here, then you do what? You reverse the what? This inequality.
Can't see the bottom of the page again.
What?
We can't see the bottom of the page again.
Oh, you can see. So if you multiply, so this statement is saying multiplying or dividing each side of an inequality by the same negative real number produces equivalent inequality, provided that what? The inequality symbol is reversed. So if you multiply here by -1, and you also multiply here by -1, then we reverse the what? The symbol there, okay? So you reverse it. All right. So an example. So each inequality, graph the solution on the number line and write the solution in interval notation. So we have this x minus 3/8 solve that one, put it in the number line, and then you write the notation. So this one is the first step. So the second step is we do what we did in the first lecture. Here, you make x the what? The sample. So you take the other values to the other side. So x minus 3/8, then plus what? 3/8 less or equals to 3/4 plus what? 3 over 8. So x is less or equals to 3 over 4 plus 3 all over 8. What is this? 3 over 4 plus 3 over 8 is what? So x is less or equals to what?
9 over 8.
9 over what?
8.
9 over 8. 9 over 8. So we represent this in the number line. So you draw like that. This is 0, that way. So 1, then 2 there. -1, -2. So where is 9 all over 8?
Above 1.
So it's likely here, right? Let's say there. And that one is like that, right? And then it goes to the what? To the negative direction. So it goes this way. So that one is the third step. Then the interval notation will be what? Negative what? Infinity, right? And then what? Okay. All right. Okay, also try this. Nine y less than 54. 9y less than 54. So what do? You divide both sides by what? So y is less than what? 54 divided by 9. What? 6? Then you draw that. 0. I say that one is 6. So which direction?
Towards the middle.
So 6 is
Greater.
greater than what? Y. So it will be that way, right? Then it comes like that. So the interval notation will be what? Negative infinity, and then what? 6. And all of them are okay. Okay, try number C and a number D. Okay. So 2x plus 1, and then you do it. Minus 1 is less than 7 minus 1. Minus 1. Okay. So 2x less than what? 6. So then you divide this one by 2, that one by 2. So x is less than what? 3. Then you draw the number like that. So here it will be 0. Then we have 3 there. So 3 is greater than x. So open that, then it goes to that direction. So this is that, and then the interval notation is negative infinity, and then what? 3. And all of them is open. Okay, then next. So negative 3x minus 2 plus what? 2 less or equals to 10. Then this one is what? Plus what? Plus. So negative 3x less or equals to what? 12. Now, here we have negative 3. So we are dividing by negative 3x. So first, here we can do what? Divide by 3, then divide by 3. So negative x less or equals to 4, right? Okay. So what is the next step? So we are dividing by what? Negative, right? So we divide by negative here, then we also divide this one by negative. So what happens? What happens? Will the sign change?
Negative times negative.
Will the sign change? Okay, read again the statement. So the statement says, multiplying or dividing each side of an inequality by the same negative real number, produces equivalent inequality, provided the direction of the inequality symbol is reversed. So are we going to reverse the inequality symbol?
Yes.
Are we going to reverse? Yeah.
I would think so. In order to get a positive number, when you're dividing from negative, you have to, negative times negative is always positive. So I think it would be the same for the x.
But in this case, we did not what? We did not introduce. It was there, right? The negative is there. So we did not introduce a new negative there.
Negative 3x.
Yeah.
So we'd be divided by negative 3.
So from my thinking, I don't think the direction of the sign will change.
divided by 3, right?
Yeah, because here the statement is saying multiplying or dividing each side of an. So this side, because this side will be positive, right? And this side will be negative. So I don't think the direction will change because the statement says if you multiply the inequality by the same negative real number, by the same negative real number. So if you multiply by negative the other side, then you also multiply by the negative in the other side. Then that's where now the direction will change. Okay?
From what I understand though, if you want to divide a negative, you like to go to the side, you have to divide it by something, you have to divide it by 1.
Yeah, even if you put negative or 1, it's still the same. Okay?
But then you divide it by a negative number.
Yeah, let's say
Still be a real number.
this is always 1. Yeah, there is always 1.
Right, but
Yeah.
that's a real number.
Yeah, real number.
That's not split. It's not split.
So if we multiply by, okay, we multiply by -1 here, then we also multiply by what? Yeah, okay, yeah, it makes sense. Okay, we will change the direction. All right. We will change the direction. So definitely it will be positive, right? So here will be negative. Some minus there. All right. Yeah, it makes sense from there. So when you draw the number line there, then there is a -4 here. Then it will go this way. So it will be -4, then positive infinity, that one's closed. All right, there's some other questions which I put them in Moodle. So choose for me the ones we can try them over here, and then maybe when you go home, you can try the rest. So which one can we do? This? Okay. All right. So first, you open the what? The bracket. So when you open the bracket, then you multiply everywhere by -4. So it will be -4x. When you multiply minus this one times this, it will be what?
Positive.
Plus what? Here's our equals to 2x plus 2x. Okay. So that that sign cannot confuse you. Okay. So that the sign cannot confuse you again, then take this one to this other side, because when you take this to the other side, then it becomes what? Positive, right? And then bring this one here. Okay. So it will be minus 4x plus 4x plus 20 greater or equals to 2x plus 4x plus 50. So this will be 0. So 20 is greater or equals to 6x plus 15. Okay, bring this one to this other side. So 20 minus 15 greater or equals to 6x plus 15 minus 15. So 20, this one is 5 greater or equals to 6x. Then you divide by 6. Then you also divide that by 6. So 5 over 6 greater or equals to x. Okay. Then you draw. So x is, so this is 0. So where are we? 5 over 6 is always less than 1, right? So x is less than or equals to 5 over 6. So which direction? Negative direction, right? So let's say it's here. Like that. So our notation would be all right. Okay. So do the same thing that like we did last week, log in, and then I will go and check. But next Friday, when I come here, I will come and call your names as I indicate present or absent. Okay, next Friday. So let's do the homeworks. The homeworks are there. So try them. If you get any difficulty, please let me know.